FPGA for medical cameras. How do you get full control, full adaptability? I'm here with Alexey Lopich, and he's the Director of Engineering at Altera, and we're here at the Embedded World in Germany. Welcome, and you have some great visuals that you can show. Can you explain the difference? If I have a phone, I think I have full control, but if you show full control, you mean something different.
Indeed.
What is full control?
What is full control? So if you have a phone, you're very likely to have something very good imaging system, as you probably have, something really nice. However, what you don't have is indeed a full control. So if you are working on applications such as medical or robotics, you need to be really, really precise in between when the image or video enters the lens and when it outputs to a surgeon or for some very, very mission critical decision making. So in order to have that full control, you need to have access to every single IP, all the memory patterns and accesses, and being able to control them and measure the latency between the input and output. Not to mention all the other parameters such as auto exposure, white balance, noise reduction, and many, many more.
And can you compare it then with my phone? What kind of control I have? I can make it darker, lighter, zoom in, zoom out. What's the difference?
Absolutely. First of all, let's start with the difference on the phone that you likely have. What you talk about control is that you're talking about the image. So yes, indeed, for the image, you can make many adjustments in software on your phone. What you cannot do on the phone is have this real-time control for the video as you do. This is number one. Number two is the control on the phone is still predetermined by the higher level software APIs that is defined by the manufacturers what allows you to do. The hardware pipeline that is on the silicon of your mobile phone is fixed. It is not fixed on the FPGA. So you can adjust it however you like. You can add new blocks, you can remove blocks if you don't need. If you have machine vision applications, you may not need beautification and better colors. If you run in, say, for example, consumer products like video conferencing, you may do need it.
Correct.
So all that flexibility is enabled by the FPGA.
Yeah, and the FPGA has AI capabilities. So how is that used over here?
So FPGA does have AI capabilities, and they can be used from entire image processing pipeline, so you can indeed do the image processing with the AI. More conventionally, you can do things like object detection, recognition, scene segmentation, maybe some medical emergency recognition. More practically, you can also use AI to tune and control the ISP or camera system. For example, when you do the autofocus or auto white balance, instead of using some abstract statistic, how much white or how many edges you have, you can recognize that these are the people or faces or object of interest, and instead I focus on them and tune the auto white balance, for example, to reflect the skin tone, or for example to autofocus to really focus on your eyes or what's really is important on the scene.
And if you have an update with a new algorithm or improved algorithm, you just update it.
You just update the hardware and the software indeed. And another, of course, thing that FPGAs are good at, unlike mobile phone, your mobile phone is tuned for a certain sensor and a certain lens. FPGAs, you can replace sensors, you can replace them with a different sensor, different resolution, different standard. Same with the output. You can have an HDMI or video over IP, so you have the entire flexibility from glass to glass.
But do not every medical application, for example, have this already, or it is
No, all the
new?
medical applications are built exactly on FPGAs for that very reason.
And how do you get started then?
How do they get started?
Yeah.
Absolutely. First of all, you download the quarters, you start to get your development kit and start prototyping. That's the easiest way to start. And then as things become more complex, this is where you design your own platform, maybe add multiple cameras, your own secret sauce, again, and this is all available.
Very flexible.
Very flexible indeed.
Alex, thanks a lot.
No problem.
Thank you for watching here from the Altera booth at the Embedded World in Germany.
Thank you.
Thank you.